हाय सो नाउ क्वेश्चन नंबर 21 को भी देख लेते हैं। इस क्वेश्चन के अंदर बोला कि हमारे पास एक रैंडम वेरिएबल x है, जो कि एक्सपोनेंशियली डिस्ट्रीब्यूटेड रैंडम वेरिएबल है। नाउ एक्सपोनेंशियली डिस्ट्रीब्यूटेड रैंडम वेरिएबल x का जो पीडीएफ होता है, सो वी कैन राइट द पीडीएफ ऑफ एक्सपोनेंशियल डिस्ट्रीब्यूशन एज लैम्डा e की पावर माइनस लैम्डा x, एंड जो इसका जो एक्सपेक्टेड वैल्यू होता है that would is generally 1 by lambda, so this lambda and this lambda are same. So now with this information we can just solve this question. So यहाँ पे हमें बोला है कि probability of x greater than equal to 2 is 0.25, right? एंड हमें वैल्यू ऑफ लैम्डा फाइंड करना है। सो एक और चीज़ जो एक्सपोनेंशियल डिस्ट्रीब्यूशन के लिए रेलेवेंट है यहाँ पे कि उसका जो सपोर्ट रहता है दैट इज 0 to infinity. ओके, सो इसको वी कैन रीराइट एज 2 less than equal to x less than infinity is 0.25. Now we can, since this is in continuous uh, continuous random variable, so to calculate the probability we can integrate over this entire range, which is 2 to infinity lambda e to the power minus lambda x dx is equals to 0.25, right? And if we'll integrate this expression now, it will come as lambda, and the lambda is constant, so e to the power minus lambda x का जो इंटीग्रल होता है that would be e to the power minus lambda x divided by minus lambda, and so it is over 2 to infinity, and this is equal to 0.25, right? So now we can just cancel this one, and minus e to the power minus infinity plus e to the power minus 2 lambda is equal to 0.25. यहाँ पे बस हमने ये डेफिनेट इंटीग्रल्स की जो वैल्यूज है उनको सब्स्टिट्यूट कर दिया, एंड वी हैव गॉट दिस एक्सप्रेशन, एंड नाउ वी कैन सॉल्व. सो दिस वैल्यू इज 0, so what we have is e to the power minus 2 lambda is equals to 0.25. Let's take the ln on both the sides. So minus 2 lambda is equals to ln of 0.25, or this can be also written as ln of 1 by 4, and this can also be written as minus ln of 4. So what we have gained here is minus to the power lambda, sorry, minus 2 lambda is equals to minus ln of 4. We can cancel the minus, and so lambda is equals to ln of 4 by 2, and by using the properties of the ln, lambda can be written as ln of 4 to the power 2, which is square root of 4, and this is equal to ln of 2. So answer to the question is ln